So today we're going to be talking about transformations, and we're going to start with reflections. Now, reflections are that was my cat going crazy. Reflections are basically, if you have the pre-image, the first shape, and you kind of flip it over a line or a point, you get the image. So in this case, we have the pre-image of the regular dog, I think that's the original. And then we have the line being this mirror right here. It's actually kind of a plane, but whatever, we'll ignore that. We have the line here, and then we have the other reflected dog over there, the image. So that's a reflection. And one crucial thing to know about reflections is that like corresponding points, like this paw and this paw right here, are the same distance away from the line of reflection. And just one quick thing here on the notation and how you would write this. The way you write a reflection is you use a lowercase r, and then in subscript below it, you do whatever the line of reflection is. So, for example, it could be a reflection over the y-axis. Now we go to rotations, which is spinning the pre-image some number of degrees around a certain point. Now I know this isn't animated, but it is in real class time, but these dogs just spin in a circle, like this. And the point they rotate around is like right about here, so there's the center point, and they just spin around in a circle like that. Now, one thing that's helpful with this, one thing good to know, the number of degrees, if it's just a positive number of degrees and they don't specify a direction, that always means counterclockwise. Counterclockwise unless they specify otherwise. Or if they were to say a negative number, like negative 90 degrees, that would mean clockwise. But the default is always counterclockwise. Now on notation for rotations, notation, rotation. That's kind of fun to say, isn't it? All right, so with that, we already have the lowercase r for reflections. So rotations, they actually got the big boy. They got the uppercase r. And what you do here is you put in subscript the number of degrees and the point, the center of rotation. So there's a few things you could see here. You might see a rotation of 180 degrees about 0.20. So what that would mean is you're taking some shape, and from the 0.20, you're going to rotate it 180 degrees around that point. Or you also might see something like this, a rotation of, say, 90 degrees with no point listed at all. If there's no point listed here, you would assume it's the origin. So on the XY axis, right here, is your center of rotation if nothing's listed. Once again, another animated slide that's not animated. All three of them were, actually. And you can picture this one, though. It's just a dog who's sliding around on a skateboard, just gliding straight through. And yeah, that's what translations are. It's just sliding a pre-image, some amount of horizontal and or vertical units. So you start with a shape or a point or something here. You just kind of slide it over here. That's a translation. And for the notation on translations, you're going to use a capital T. And then what you're going to do is you're going to do how far it goes left to right. I hope you guys couldn't hear my cat grunting into the microphone there, because that would have been weird. And then comma, how far it goes up and down. So this is like a little complicated, but not super terrible. And it just kind of follows the XY axis. So like if something goes left, it's negative. If it goes right, it's positive. If it goes up, it's positive. And if it goes down, it's negative. So you just think of it like literally like this. Positives are over here, negatives are over here, positives up here, negatives over here. So if you have a translation of 6, -2, what it means is it goes right 6 and then down 2. Or if you have a translation of -3, 4, it means it goes left 3 and then up 4. And the last one we're going to deal with is dilations. So dilations is either enlarging a shape or shrinking a shape according to a certain ratio, which is called a scale factor. We're going to get into that in a much bigger way in the next couple of units. So like this, we have this tiny little dog. and then the dog gets bigger, and the dog gets huge. So that's one way to dilate. You can get bigger, or it's also a dilation if we look at it this way in some unnatural, not nature sanctioned way of going from the big dog down to the little small dog like that. And the notation for dilations is just a capital D with the scale factor in subscript below. So you could have a dilation of 3, or you could have a dilation of 2/3. Now in this, 3 is actually going to get bigger, 2/3 is going to get smaller. Any scale factor less than 1, so fractional scale factors like this, as long as we're talking positive, we'll get to negatives, but it's sort of a different area that we're not really going to worry about right now. But so between 0 and 1, these scale factors will always make the shape smaller. If it's above 1, like this, it makes the shape bigger. So now we get to a phrase that the New York State Regents loves. It's called rigid motions. And rigid motions are any transformation where the image and the pre-image are congruent. Now remember that congruent means the same size and the same shape. So if we look at these and we try to figure out which ones of these are the same size, same shape. So reflections, those aren't going to change any size. So yes, that is a rigid motion, 100%. Rotations, that's just spinning around. So again, same size, same shape. Translations, also, that's just sliding the shape. So that's also a rigid motion. In fact, it doesn't even like change direction. It looks pretty much the same thing, just in a slightly different place. Now dilations, remember, those shapes can get bigger or smaller, so that is not the same size. So dilations are a big fat no to rigid motion. So anytime you see the phrase rigid motions, they're talking about either a reflection, a rotation, or a translation. Okay, so now we're going to look at PacMan. And we're going to ignore how open his mouth is in these things because it's kind of hard to get a screenshot at exactly the right time. I'm sorry. But we're just going to look at like the way he's facing and how he got there. So with this, how did he get from this to this? If you look at it, he's facing towards the right here, and now he's facing towards the left. So the way, if you actually watch PacMan do it, he doesn't actually like rotate all the way around. He just flips immediately. So right there, that's actually a reflection to go from that first PacMan to the second PacMan. And of course a translation too. I mean, both of these are going to have translations. But, you know, because he's moving from side to side across the screen, so he's going to move, or up and down. All right, now this one. To get from here to here, he had to translate over here, and then he rotated upward to get here, and also translated a little bit there too. So like, yeah, the translation's still around. Cool, cool, fun, fun. And the big one here is a rotation. And he actually, in this case, he rotates like you can think of him as right here, and he rotates clockwise 90 degrees to get up to there.